Page 8 of complex number and polynomials. We're starting section C. And polynomial functions can be expressed in two forms. One is the top one where everything's broken out into separate terms, starting with the x to the n term, x to the n minus 1 term, and so on until finally get to the a to the 0, which is the constant term without any x variable multiplying times it. Or you can write it as a summation, and the summation basically writes each term just as one term inside the summation, a to the r, x to the r, and then it has an index that counts up from 0 to n, which represents each term index. And then if you cycle through the summation, then it adds them all together. So the symbols in both of these expressions is defined by, for example, x would be the variable, and a0 would be the last coefficient, known as the constant term. And a to the n is the first coefficient, also known as the leading coefficient. A to the r is the rth coefficient, and it is the rth coefficient, which is multiplied times the x to the r term, the x to the r variable. And finally, n is the degree of the polynomial. It is also equal to, it's related to the number of terms. Okay, so the number of terms would be n plus 1. Okay, let's read through this paragraph here. In a real polynomial p to the x, the values of a to the r are coefficients. A function with n equal 2 is called a quadratic. With n equals 3 is called a cubic. N equals 4 is called a quartic. And for these cases, the coefficients are frequently written as a, b, c, d, e, instead of as a to the r. Okay, so remember, like for a quadratic, we often say ax squared plus bx plus c. That would be the first three of these coefficients, right? Instead of saying a subscript 2, b subscript 1, or a subscript 2, a subscript 1, a subscript 0, for example. Okay? Now we're on 6c1. Number 1. If the polynomial x squared plus 2x plus 3, which is a quadratic, and q equals 4x squared plus 5x plus 6, find in simplest term 3 times the polynomial. Okay, this is really basic, right? So I'm going to multiply 3 times this polynomial. Just distribute the 3. 3x squared plus 6x plus 9. Okay? And then now we're going to do something a little bit more complicated. We're going to take p, which is x squared plus 2x plus 3, and I'm going to subtract 2q. So that would be minus 2 times 4, which is negative 8x squared, minus 2 times 5, which is minus 10x, and minus 2 times 6, which is minus 12. Then I add one to the other, and it'll be negative 7x squared, minus 8x, and minus 9. So that would be our result. Let's do 3a. So we are just going to multiply a quadratic times a binomial, and you could do what do you call it? Lattice multiplication for this. So I'll have x squared minus 2x plus 3. I'm going to multiply that times 2x plus 1, and then I'm going to write each one of the multiplication results here. So it would be 2x cubed minus 4x squared plus 6x. This would be 3, 2, negative 2x, and x squared. And then I'm going to add them in diagonal lines like this. So I'll get 2x cubed plus x, oh, wait a second. So I'm going to add negative 4x squared and 2x, or x squared, and I'll get negative 3x squared. And then I'm going to add 6x and 2x, I'm going to get 4x, and then I'm going to add 3. So basically I get 2x cubed minus 3x squared plus 4x plus 3. Okay, let's do C. By the way, the answer here is that, right? C. Now this is the same binomial multiplied times L 3 times. So I don't want you to do lattice multiplication. I don't want you to do distributive property or FOIL or whatever. I want you to use binomial expansion, right? So write all the coefficients out for the third row of Pascal's triangle. It'll be 1, 3, 3, 1. The first term was the x term, so it would be x to the third, x squared, x to the first, and then x to the 0. For the 2, we count backwards, so it would be 2 to the 0, 2 to the 0, 2 to the first, 2 squared, and then 2 cubed, which is 8. Okay, and everything's plus because both terms are positive, so we end up with x cubed plus 6x squared plus 12x plus 8. Here we have binomial expansion with n equals 4, so the Pascal's triangle row is 1, 4, 6, 4, 1. The first term is 2x to the fourth, 2x cubed, 2x squared, and 2x. And then the second term is negative 1, so the first term it would be negative 1 to the 0, which is just 1, and the second term would be negative 1 to the first, so that would be negative there. The third term would be negative 1 squared, which would be positive, and so on. So it would be like that, right? And so now we'll expand. So we'll have 2 to the fourth, which is 16, x to the fourth. And then we'll have 2 cubed, which is 8. So it'd be negative 32 x cubed. Then we'll have 2 squared, which is 4. So it'd be 24x. And then we'll have 2 times 4, which is 8. Negative 8x. Oh, this would be squared, right? And then plus 1. And that's correct. Let's go down to the last problem. Find the following products. So again, I prefer to do lattice multiplication on these. Less chance for error. So first, let's do this first one. And so we'll have 2x squared times 3x, that would be 6x cubed. Negative 3x times 3x, that'd be negative 9x squared. 5 times 3x would be 15x. The bottom row would be negative 2x squared, positive 3x, and negative 5. And then we're going to add the rows diagonally, and we'll get 6x cubed for the first term, negative 11x squared for the second term, 18x for the third term, and negative 5 for the fourth term. So basically the answer should be that. When you do lattice multiplication with this one, be careful because 5 minus x is in the opposite order of what we're used to. It should be negative 5 plus x, negative x plus 5. So if we put it in the proper order, it looks like that. So 2x squared times negative x would be negative 2x cubed. Negative x times 3x would be negative 3x squared. Negative x times 2 is negative 2x. 5 times 2x squared is 10x squared. 5 times 3x is 15x. 5 times 2 is 10. And then negative 2x cubed, 7x squared, 13x plus 10. Finally, for E, I'm going to show you the technique that the book uses, which is it basically just takes the coefficients and it kind of does like a multi-digit multiplication type thing, just like we do with third grade multiplication when we multiply 256 times 182. So we'll put like 1, -3, 2 to represent the coefficients in the first polynomial. And then we'll put 2, 4, -1 to represent the coefficients in the second polynomial. And then we'll multiply kind of like the way we do it in elementary school. We'll multiply -1 times each one of those and rewrite everything right underneath like that. And then when we multiply by 4, we write, you know, up to here. So like the first one would be in this position, and the second one would be this position, and 4 times 2 would be in this position, okay? And so it's very similar to multiplying regular numbers. So 2 times 2 is 4, 2 times -3 is -6, 2 times 1 is 2. One thing that's easier is you never have to carry anything, right? So when you exceed 10, you keep it there. -12, -13, -9, -2, and 2. And then you just translate these numbers into degrees of x. So this would be the constant term. This would be the x term, x squared, x cubed, and x to the fourth. So we end up with 2x to the fourth plus, or I'm sorry, 2x to the fourth minus 2x cubed minus 9x squared plus 11x minus 2.